Hello there. Welcome to the world of the universe. My name is Oak. People call me the Nebula Professor. This world is inhabited by entities called stars. For some people, stars are merely objects in the sky. Myself, I study Starmon as a profession. Your very own cosmologic adventure is about to unfold. A world of dreams and adventures await. Let's go. Come back. I want to tell you about my research on the evolution of stars. All stars begin their life in a big gas cloud called a nebula. Within this cloud, there are regions where gravity pulls the dust and gas together. When the pull of gravity becomes great enough, the gravitational attraction of the particles is greater than the random motion of the particles, the cloud will collapse into a brand new baby star that we call a protostar. Protostars do not have the mass needed to fully express their power, and so they tend to be rather dim. Eventually, in these baby stars, nuclear fusion begins and the star is truly born. Once the baby star has grown enough in mass, it will transform into a main sequence star, the primary evolutionary stage of Starmon. Look, our baby star is growing up. Let's watch. From here, it is to note that my research focuses mostly on stars who are pretty small, less than 4 solar masses. In this stage, Starmon fuse hydrogen into helium and radiate massive amounts of energy into space. Our favorite Starmon, the Sun, is in its primary stage as well. This stage is longest for the early life of a Starmon and can last for around 10 million years. Once a Starmon has battled extensively and used up about 12% of its hydrogen stores, it will evolve into its secondary stage of life. The evolutionary process is brutal, requiring the Starmon's core to collapse. But the increasing pressure and fuel in the core allows for fusion to restart, and the star enters its second phase, the red giant stage. In this stage, the Starmon increases in size dramatically. Most of the time, within this stage, the Starmon will absorb its surrounding planetmons and other Starmons. Additionally, it will continue to burn hydrogen into helium, but with the bigger of these varieties, it may also begin to burn helium into heavier elements like carbon, nitrogen, and oxygen. When the Starmon once again uses 12% of the element used to sustain fusion, hydrogen in the inner core and helium in the outer core, the radiation pressure once again cannot overcome gravity, so the core of the Starmon collapses a second time and its final evolution occurs. However, this time, the Starmon is unable to hold on to most of its mass, so it is expelled into space in an event called a planetary nebula. After the Starmon has released most of its mass in the planetary nebula, it becomes a white dwarf. These stellar objects are very hot, yet very dim. The Starmon is then predicted to gradually cool off and become a black dwarf. However, this process can take up to 10 to the 200th power years. A white dwarf Starmon is sustained by electron degeneracy pressure. This pressure is explained by the Pauli exclusion principle, which states that two electrons cannot have the same quantum properties. Nevertheless, according to the Chandrasekhar limit, white dwarfs cannot exceed 1.4 solar masses, since the electron degeneracy pressure would be unable to overcome the resulting gravity. Thank you for indulging me in my research. Now, your very own cosmologic adventure is about to unfold. A world of dreams and adventures await. Let's go.